let's take a look at question 17. In question 17, we're going to be learning how to find the domain and range of a function graphically. Okay? Alright, question 17 says the function f of x is graphed below. So this looks like part of an absolute value function. Okay, why do we say it's part of an absolute value function? It is part of an absolute value function because we know that the absolute function increases forever to the left and to the right. But in this particular function, it stops short in the left end. Okay, it stops right there. So it doesn't increase forever to the left. Okay, so it's a portion of an absolute value function, not a complete absolute value function. Alright? The question is, the domain of this function is... So what is the domain of this function? Before we do that, there's something you want to remember, which is basically what the domain and the range mean graphically. Okay, so recall, this is concerning domain and range. The domain is what? The domain is the width or horizontal span of your graph. Alright, how far to the left does the graph cover and how far to the right does the graph cover if it is projected down to the x-axis. Okay? And then the range represents what? Guess what it is? The range represents the height or the vertical span. How high can you go and how low can you go? Alright? How high can you go, how low can you go if the graph is projected on the y-axis? Okay, so if you think about projection, think about shadows. Okay, if a shadow is cast on the ground or on the wall, how wide is the shadow or how tall is the shadow? That's basically what we are talking about here. In this particular problem, we're asked to find the domain. So let's go ahead and figure what that is, and then I will show you what the range is so you can see the difference between both of them. Let's make our arrow pretty thin. Okay, so for the domain, what we're going to do is we're going to project this graph onto the x-axis. So what does that mean? You go straight down from the starting point, straight down, a line perpendicular to the x-axis. That's a straight down projection. And then this one will be projected straight down too. Alright, so how do these projections come about? Now imagine that there's a flashlight, a big powerful flashlight up here, flashing a light on this function. Okay, the shadow that this function casts on the x-axis or the floor is basically what the domain is. Alright, so that's the shadow is going to be right here. So we have, what are we going to have? This left point is a closed circle, so it's going to project a closed circle here. So starting from this point, whatever that is, that's -1. Starting from this point, is going to span everything in between all the way. Now this end right here is an arrow. Do you know what that means? It means that it keeps on going forever. So the projection will be an arrow also. Okay, so this point is projected as a point. This line right here is this entire interval. And then this arrow basically means that the projection will continue forever. No matter how far you go to the right, you will have a shadow being cast because the function keeps on going. Okay? Alright, so if you take a look at this weird number line we just drew, going from what? -1 all the way to infinity, that is the domain of our function. Okay? So if we want to write this down in interval notation, it's going to be from -1 to infinity. But if we want to write it using inequality notation, it's going to be x is what? X starts from -1 and goes on to infinity. So x is greater than, and since it's a closed circle, equal to -1. Alright? So our answer for question number 17 is option number 4. Alright, now this problem doesn't ask for range, but we might as well figure it out anyway, because on the next Regents exam you might be asked to find what the range is. So what is the range of this function? Do you see what the range is? Now, since we have the portion of the function to the left and right, we're going to have to use two flashlights. We're going to need a flashlight to the left and a flashlight to the right, and then we're going to unite the two shadows that we get. All right. So from the left side, this one gets projected on here as a point, and then from the right side, this gets projected to the top as an arrow. Okay, but since this is above, it has a line here, so we're gonna have so let me draw my arrow properly. It's looking weird. All right, so there goes my arrow right there. Draw it again. So we have an arrow going up. Okay. All right, so from the left side is this point going all the way down. So this this vertex right here is projected as a point on the y-axis. Okay. So from the left side we have this point and everything beneath. Bam, 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 all the way to 0. But from the right, we have this arrow, and guess what? Everything beneath. Okay, so basically extends the domain. So the domain basically the range basically starts from 0, and guess what? It goes up forever. Okay? Up and up, all the way to infinity. So what's the range going to be in this particular case? The range, which goes with the y, the range or the vertical span is going to go from 0 to infinity using interval notation, or using inequality notation is going to be y is greater than or equal to 0. So if you look at this distractor here, number 3, that's terrible because it has x. When you're dealing with the range, you use y, or you can write f of x is greater than or equal to 0. So the notation alone can automatically help you to determine which is applicable. Alright, so this is the range from 0 to infinity, or y greater than 0 or equal to 0, and the domain is -1 to infinity, or x is greater than or equal to -1.